So basically, a fundamental concept of any computer science is algorithms, data structures, and computational thinking. So algorithms is nothing but a step-by-step procedure or instructions for solving a problem and performing tasks. And just to be noted that the word algorithm comes from the person Al-Khwarizmi in law in the Islamic times. He discovered the step-by-step procedure of instruction. So the Al-Khwarizmi transformed to algorithm, and the step-by-step solving process is called algorithm. And data structures is basically organized formats of storing and managing a data efficiently. So previously we used to organize the data in paper, and this data was organized in paper format. Then once we had computers, this data was stored in computer structures like in Excel or in Word or any other software. And computational thinking is problem solving approach that involves breaking down a complex problem into smaller manageable parts and developing algorithms to solve them. So computational thinking is you devise a standard pattern and then let the computer do the work for you in a repetitive manner. So you break down a complex problem, put it into small manageable steps, and then execute one problem at a time. And this is what an algorithm is. And one solving computers are great in solving one problem at a time, which it does in a sequential fashion. And this is the whole fundamental concept. So you have algorithms which basically works on the data, and data which is the actual data itself, and then computational thinking, which basically is the you write a program or algorithm to solve a specific problem. So this is a course on computer science. This is a very comprehensive course. I'll start with basics like what encompasses computer science, what are the basics, and then go on to application programming, like what are the applications which run on Windows, and then I'll go on to embedded systems, which basically small applications running on the small devices or electronic devices which you will use. Then I'll briefly touch on web and mobile app applications, what it is. It is a very general course for anyone who begins to start with computer science or IT topics. It will cover most of the aspects. This course will grow over time. That is, it will be initially 30 minutes, and then it will grow as the time passes. So keep a check on this course. So any computer or laptop will have a monitor, a keyboard, and a CPU. So monitor is what you see, and keyboard or mouse is what you give the data as input commands, and then CPU is the whole thing which processes and gives you the thing. So this is the fundamental structure of any basic computer. Inside the CPU you will have more complex structures, which I'm not going to go detail, but just understand that these three are important things, that is input, output, and the processing. So computer science basically encompasses a broad range of topics, but at its core it deals with computers, computer systems, and everything surrounding a computer science. That is, computer science was formed, like started in 1980s. Even then it started 1990s. You had the internet, then everything started to boom. Then you had slowly, once the internet came, there's a lot of knowledge exchange, which and computer science or the computers basically help to do many tasks faster. And nowadays you have more advanced things like artificial intelligence and stuff. So I'll go into one at a time, the topics, and then hope you will understand it. And as for programming languages, basically these are languages which the computer understands. These are written in English like C, C++ or Python. These are English keywords which one set of computer language will have a standard syntax. Like, for example, we have English, I have Chinese, we have Arabic, we have Tamil, we have Hindi, a lot of German, other languages which have standard syntax. Like that, programming languages are also having standard syntax and semantics, and the rules structure governing the writing of code in programming language. And these languages, and it has variables and data types, which is representation of data in memory, such as integers, strings, and booleans. Like in maths, we have integers like a floating point, which are decimal values, and we have strings which are just characters. So like that, the same maths things are transformed in computer science. We call it variables and data types. Control structures, controls like loops and conditionals for controlling the flow of programming execution. That is, after one step that you go to the next step, and the next step, if there are multiple options, then it goes a control structure. This is what we call a control structure. Functions and methods. Reusable blocks of code are called functions or methods which perform a specific task. And object-oriented programming is a paradigm based on concepts of objects which encapsulate data and behavior. So object-oriented programming is C++, Java are all object-oriented. Why we call it object-oriented is you have a standard template which can be reused. In C programming, it's procedural language, you have a lot of functions. These functions cannot be reused. But in C++ or Java, you can create a sort of libraries which can be used in other C++ programs. So that's why we call it object oriented. So the class is as a template, and object is the living or the running code is called an object. Hi, my name is Kaja. I have over 20 years of software development experience with various clients, and I have worked in software development, testing, cloud computing, artificial intelligence. And I'm basically an IT consultant, and this course is about cloud computing. So here I'll talk about Amazon Web Services, AWS, Microsoft Azure, and Heroku, three main platforms, and others like Google. So here I'll teach you about the basics so that it's easy to understand with the concepts, and anyone, if you're a beginner in IT or computer science, or a student or a professional who wants to switch career to cloud computing, this is the best course. So go on, have a look at the course, and I have also suggested a small project. Do as far as possible, and if you have any questions you can contact me. It's just like a small website development and how you host it on any any cloud computing platform like AWS, Azure, or Heroku. Heroku is the easiest one. And any questions you can contact me. So go on. Let's meet in the course. So in this video, in this tutorial, you will learn about cloud computing from the very basics till advanced level. So initial will be a 30 minutes course, and then it will be updated regularly. So do have a look at it regularly, keep checking the video, keep checking this course regularly. So cloud computing, basically, when you see as an overview, cloud computing is the delivery of computing services over the internet, that is allowing individuals and businesses to access and use computing resources such as servers, storage, databases, networking, software, etc. on the network. So that is, you access any software or any server or anything remotely. So that is the concept. Like for example, if you are using Amazon Web Services, or if you are using Microsoft 365 Word or email in the browser, everything is you're accessing over the cloud. That is, some server is hosting those applications and you're accessing it remotely, and you pay as it works as a pay as you go basis. That is, you pay monthly subscription sort of things. So that is the basic idea of cloud computing. That is, you have just your computer, and then you're accessing very powerful hardware or software resources which is installed in some remote computer remotely, and you access it from your own system. So that is basically is what the basic fundamental definition of cloud computing. So key characteristics of cloud computing are on-demand self-service, broad network access, resource pooling, rapid elasticity, measured service. So of these, on-demand self-service means users can provision computing capabilities such as server time and network storage as needed automatically without requiring human intervention with each service provider. So what it means is like the server time and network storage. These are some of the services or the hardware resources which you access depending on demand. That is, depending on your demand. Without human intervention means like Each you will be allocated your specific time, server time or network time on demand basis. So this is what you call on demand self-service. Broad network access means resources are available over the network and access through standard mechanisms that promote the use of heterogeneous thin or thick client platforms. So this is another form of cloud computing where resources are available over the network and is accessed through mobiles, tablets, or workstations. Resource pooling is providers computing resources are pooled and to serve multiple consumers using a multi-tenant model with different physical virtual resources dynamically assigned and reassigned according to the consumer demand. So resource pooling basically means certain physical virtual resources are assigned to say person A at a specific time. Then once he finishes his use, then the same thing is assigned to someone else on their consumer demand. So it switches, the resources being switched between different people, and that's what we call resource pooling. Rapid elasticity capabilities can be elastically provisioned and released to scale rapidly outward and inward with demand. To the consumer, the capabilities available for provisioning often appear unlimited and can be appropriated in any quantity of time. So rapid elasticity is also a sort of sharing, elastically sharing, and which is basically provisioned and released depending on the outward and inward demand. So depending on the demand, something is provisioned or released. And for the consumer, they don't see the difference. So they will be allocated a specific resource from say computer A located at say USA, and then after some time, if they are doing some action, they might be allocated a resource a computer B from Europe, depending on the demand. And measured services, cloud systems automatically control and optimize the resource used by leveraging a metering capability at some level of abstraction appropriate to the type of service. Example, storage, processing, bandwidth, and active user account. So resource usage can be monitored and reported, providing transparency for both the provider and the consumer of the utilized service. So these are some of the key characteristics of cloud computing. I know it's a bit heavy, but just it's an introduction. Later I'll go deep into the topic. So on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. So some of the types of cloud computing services are infrastructure as a service, platform as a service, software as a service. Infrastructure as a service means provides virtualized computing resources over the internet. Examples are Amazon EC2, Microsoft Azure virtual machines, Google Compute Engine. And users can rent virtual machines, storage, and networks, and are responsible for managing the operating system, applications, and middleware. So this is the infrastructure of a service. That is, you basically rent or get a computer remotely, a Linux or any system remote like EC2 in the case. I'll show some examples later. And the infrastructure is offered as a service. So you don't have to have physically any hardware, but you can just use this remotely from your computer, and it almost is the same. Platform as a service provides a platform allowing customers to develop, run, and manage applications without complexity of building and maintaining underlying infrastructure. So you can run applications if your application needs say Tomcat server, Java, and certain Java and JSP, then it needs some hardware or software to run on, right? So this service will be provided, this platform will be provided. And examples are Google App Engine, Microsoft Azure App Services, or Heroku. Heroku, for example, it gives you a way where you can run your applications on Heroku systems, or you can buy a Ubuntu system and then install all your software which is needed and then run the application. So users focus on application development while provider manages the infrastructure, operating systems, and the middleware. So platform as a service means they will provide you the platform, and then you run your applications over that platform. Then software as a service is delivers the software applications over the internet on a subscription basis. Examples are Google Workspace, formerly G Suite, Microsoft Office 365, and Salesforce. So users access applications over the internet without managing underlying infrastructure. Basically, you access the software itself directly remotely, and you don't worry about anything. You just pay a subscription, and then you use the software on a remote in a remote computer. So these are main three computing services: infrastructure as a service, platform as a service, and software as a service. So cloud deployment model types are public cloud, basically, and private cloud, hybrid cloud, and multi-cloud. So public cloud means services are delivered over the public internet and shared across multiple organizations. Examples are AWS, Microsoft Azure Cloud Computing Platform. Cost effective and scalable, but may have security and compliance concerns for certain sensitive data. So this is a public cloud, so it's basically available for everyone to use and is shared. So this is delivered as a public internet and shared across multiple organizations. Cloud infrastructure, private cloud is exclusively operated for a single organization, can be managed internally or by third party, hosted on the premise and off premise, offers a greater control and customizations, is expensive. Private cloud means you will have a dedicated server only for your system, only for your company, in your company or wherever your company told you, or in a different location, but it will be allocated only for you. No one will have access, no one else will have access. In contrast to public cloud, where the servers will be accessed by many people, but they will have definitely their own login, password, and security mechanism, but it will be accessible to different people. That's the main difference. Hybrid cloud combines public and private clouds, allowing data and applications to be shared between them, provides greater flexibility, optimize existing infrastructure, security, and compliance, suitable for handling dynamic and highly changeable workloads. So hybrid is, you will have public and private, and allowing data and applications, everything is shared between different people, and provides greater flexibility and optimism. So if you are running an application which is small now, but later it might have, say, if you're having 100 users now and it could reach more users, then it's flexible. So it's like elastic thing, just changes the workload depending on the demand. The cloud expands or contracts. Multi-cloud is how use of multiple cloud computing services from different providers, and helps avoid vendor lock, can optimize performance. So multi-cloud is many systems to work together like AWS, Microsoft, and depending on your demands you can switch between different providers. So that is what is multi-cloud. These are the four deployment models: public cloud, private cloud, hybrid cloud, and multi-cloud. So benefits of cloud computing are cost efficiency, scalability, performance, speed and agility, and security. So cost efficiency means eliminates the capital expense of buying hardware, software, setting up, etc. So if you're a company, you want to buy hardware, software, everything, you have to invest, and then you need a premise to store the hardware, and you need admin, everything. So you don't have this if you're using cloud computing. Scalability, scale resources. So as the same, if you are installing hardware, then your company grows, then you need to scale up here, or if you're scaling down, then also you need to scale down. So these are things which you can easily do with cloud computing. Performance, major cloud services run on a worldwide network of secure data centers, providing consistently fast performance and high availability. So these are big companies mostly providing, like Google, Amazon, Microsoft, who have a lot of money, so they invest in a lot of servers, and they can give you 24 hours, 365 days performance and availability. Speed, agility, vast amounts of computing resources can be provisioned in minutes, giving businesses a lot of flexibility and taking pressure capacity of planning. So speed is there. If you want to start something quickly, then they are there to provide you quickly. Security is main. Many cloud providers offer set of policies, technologies, and controls that strengthen the security overall, helping protect data, apps, and infrastructure. Security is another thing. So now we have dedicated solutions to provide secure cloud services. Like if you see 10-15 years back, there was not a concept. You might have seen that 15-20 years back, every company had their own admin. Nowadays, you see admins are hardly visible because mostly is managed remotely and done by clouds. So these are some of the benefits of cloud computing. So common use cases of cloud computing are data storage and backup, and disaster recovery, web hosting, big data analytics, development and testing, artificial intelligence, machine learning, collaboration and productivity. So data storage and backup means storing and backing up of data securely on the cloud with access from anywhere. So this is like when you save something, everything is backed up some in another remote system, so that even something, your system gets corrupt or the cloud server is gone offline, then you still have some place to access the data from the backup. Disaster recovery, implementing disaster recovery solutions without cost of second physical site. So all this is managed for you. So it's a good thing that you have a duplicate system where everything is stored and disaster recovery can be done quickly. Web hosting services and blocks, scalable infrastructure, and big data analytics, analyzing large data sets to gain business insights and trends. Development and testing, quickly creating development and test environments tailored to specific needs. Artificial intelligence and machine learning, leveraging on cloud-based AI ML services for predictive analytics and data processing. Collaboration and productivity, using cloud-based tools for team collaboration, communication, and productivity. Google Workspace, Microsoft 365. These are some of the common use cases for cloud computing. So concluding, cloud computing has revolutionized the way businesses operate, and many of these concepts, like during COVID, many people started to work remotely, and now also work from home and remote is possible because of cloud computing, because without that you don't have a remote access to any of your company resources. Revolutionized the way businesses operate, scale flexible and cost-effective solutions for a wide range of computing needs, whether IaaS or platform as a service, software as a service, whether deployed in public, private, hybrid, or multi-cloud environments. Cloud computing offers a significant advantage in terms of efficiency, scalability, and security. So it's a very important technology, and it has revolutionized the way we work because of this technology. So now let's look at Azure, Microsoft Azure. Azure is a Microsoft product, and Microsoft Azure, commonly referred to as Azure, is a cloud computing service created by Microsoft. It provides a wide range of cloud services like computing, analytics, storage, and networking, and also AI solutions. So this is all basically remote resources you can access from anywhere. So that's what Microsoft Azure is. So key features of Azure are virtual machines. Azure offers scalable VMs to run various operating systems and applications. So this is remote, basically remote systems. App services, platform as a service to build, deploy, scale web apps and APIs. Azure Kubernetes Services, AKS, is managed Kubernetes service for running containerized applications. Storage capabilities, like scalable storage solutions including blob storage, disk storage, and file storage. Databases, managed database services like Azure SQL Database, Cosmos DB, Azure Database for PostgreSQL and MySQL. AI, machine learning, cognitive services, Azure ML, bot services, and integrating AI capabilities. Analytics services like Azure Synapse Analytics and HD Insight for big data analytics and data warehousing. Networking, virtual networks, load balancers, VPN gateway, and Azure DNS for network solutions. DevOps, Azure DevOps for continuous integration, continuous pipelines, Azure repos, and Azure boards for agile project management. And security and identity, Azure Active Directory, Azure Security Center, Azure Key Vault for identity management and security. So these are some of the key main services which Azure provides. The same thing, like you want to use a software, you can just access it remotely. You want to use a system like Linux, Ubuntu, or a Windows system, you'll get a virtual machine. Applications you can get remotely. That's what databases, you can access remote databases. Storage solution, you can storage data anywhere. AI and machine learning, like if you want to use any specific AI and machine learning solutions, bot services, you can access it remotely. Analytics solutions, networking, DevOps, and security, identity, Active Directory, or people management. So all these are key features of Azure. So use cases of Azure is same like what I said: hosting web applications, data analytics and warehousing, machine learning and AI, IoT applications, DevOps and agile development, disaster recovery and backup solutions. So these are some of the use cases of Microsoft Azure. Similar to what I showed in AWS, Azure, Microsoft Azure also has similar functionality, that is MySQL on a remote system. So when I search MySQL, they are offering you a system and a plan and a pricing, which is basically running on a Ubuntu server. That is, they have a remote Ubuntu server over which MySQL is installed, and they will give you access for it. And this is start with trial, and then it goes up as the more you use, the more it becomes expensive on that. So this is a similar functionality which I just showed you with AWS, and you can use Microsoft Azure MySQL Cloud. And the process for login is you create an account, and then you have different Azure services which you can select, and then basically create a new database similar to what I did in AWS, and you're good to go. So you have a remote MySQL database which you can basically connect. So there are different features or services also Microsoft Azure offers, like what you see here, and you can search for MySQL or other services. You see a lot of you have containers, databases, so you can create different kinds of databases in Azure, any like Oracle or MariaDB or anything, and then host it on Microsoft Azure and link with your application. So here I'm not creating a database, I'm just showing you some stuff like where you initially log in, because I've had some trouble in logging in and creating a database in the free tier, which I have to see how I can do that later, but it gives you an example. So it's exactly the same as like you do for AWS. You create an account in Microsoft Azure, created any database, and you can link with it. So that's the basic idea. So AWS, Amazon Web Services, similar to Azure. Amazon Web Services is a subsidiary of Amazon, and AWS is Amazon subsidiary of Amazon, providing on-demand and cloud computing platforms and APIs for individuals and companies and governments. It's a web service, it's a cloud service offered by the company Amazon, because they have a lot of servers from which you can access certain resources. So key features is the same. You have EC2, Elastic Computing Cloud, scalable virtual servers for various computing needs. S3, Simple Storage Service, object-oriented object storage service for scalable data storage, basically store data like Google Drive and stuff. RDS, Relational Database Service, managed relational databases including Amazon Aurora, MySQL, PostgreSQL, and Oracle. Lambda, serverless computing for running code without provisioning servers. EKS is Elastic Kubernetes Service, managed Kubernetes service for container orchestration. AI and machine learning, SageMaker for machine learning, recognition for image analysis, and Comprehend for natural language processing. Analytics services like Redshift for data warehousing, Athena for SQL queries on S3, and EMR for big data processing. Networking is VPC, virtual private cloud, CloudFront CDN, and Route 53 DNS. DevOps code pipeline for CI/CD, code build for building code, and code deploy for application deployment. Security and identity, IAM identity and access management, AWS Shield and AWS WAF security. So these are typical things like basically storage capacities or remote computers you need, or any space, any certain AI machine learning applications you need. These are all provided by Amazon Web Services. All the use cases are the same like before: hosting, scaling web applications, data lakes and big data processing, machine learning and AI development, IoT applications, enterprise IT and business applications, backup and disaster recovery. So these are typical use cases for AWS. So in this video, you'll learn about AWS Beanstalk, which is a platform as a service from Amazon AWS company. So AWS Elastic Beanstalk is a platform as a service. So there are different kinds of cloud computing services, which I said before, like software as a service, platform as a service, infrastructure as a service. And in the case of AWS Elastic Beanstalk, it's a platform as a service offered by Amazon Web Services. So this basically simplifies the process of deploying and managing applications. So what does it mean? Deploying, managing applications means like if you are running any website, for example, if you're developing a website which does some calculations, for example, if you're buying, selling, or you have user registration, or it does some like artificial intelligence functions or something like that, then you need to deploy that application somewhere. It's not a static website. It's a like if you're connecting to a database. So these are dynamic websites. So these are not only websites, these are applications. So these applications need to be located in some server, and that's what we call deploying and managing the applications in the cloud. So this AWS Beanstalk supports that. So you can create website applications, web applications, and install it on their servers, and make it available for the general public. So it supports various languages like Java, .NET, PHP, Node.js, Ruby, Go. So what it means is it supports means like if you develop any web application with Java, .NET, PHP, or any of these technologies, it enables you to install on their server. So the key features include like easy deployment and auto scaling. So you can quickly deploy your application. So if you see Elastic Beanstalk, you can the process of application installation is quite straightforward. It handles provisioning and necessary resources like servers, load balancers, and data. Load balancers is depending on the traffic of your web application. It will balance how much resource it needs. So that's what we call load balance. So it's easy deployment, and auto scaling is automatically scales your application based on traffic, ensuring optimal performance without manual intervention. So depending on if there are 10 users now, and if another 3 months time there are 100 users, the system automatically recognizes it and gives the performance or increases the hardware capacity automatically without any human intervention. And depending on that, you will be also charged. So this is what is AWS Beanstalk. So the other aspects like monitoring and management, AWS Beanstalk provides tools for monitoring application health and performance with integrated logging and metrics. And it's customizable, that is, you can customize the underlying resources and configuration through configuration files and management console. Integration, it integrates well with other AWS services, allowing for a seamless experience in building and scaling applications. So it integrates well with other services, and you can run different services together. So overall, AWS Beanstalk is designed to make it easier for developers to deploy applications without worrying about the infrastructure. So you just have to get your application ready, and if it runs locally, you just package it and you can install it on the Beanstalk and link it to the domain and then make the system available. So it's quite easy and customizable. Here you'll see this is AWS Beanstalk. So this is the console. After you made an account with, you can create applications, and this is the toolbar where you can see all the services offered: console, Elastic IAM, access AWS resources, EC2, and different Elastic Beanstalk is the first one. And if you click that, you will be taken to a page like this where you can create environment first and then applications. So you have applications, environments, and I have done some small applications. Like here I tried to create an application name. This is the process. You create a test application, and then you click on the create button, and after that you need to create an environment. It could be a web server or a work environment, and depending on the settings. So most of the things initially you can just use standard like manage platform, sample application, and you can select different platforms, that is whichever your application you are installing. If it's running on a Tomcat server, then you select the Tomcat with different versions here, and if it's a different platform you select accordingly, and then you go. So here I'm just selecting sample, or you can put existing version or upload your code. So if you are making an upload of your code, then you have to select your specific code base, and then so here for test I'm just selecting sample application, and that will take you to the next set of settings. So for example, here use a existing service role. Service role is something which you, if you don't have this, then you create a new one. So the service role is an essential thing, and the others you can leave as it is, and then others you can just skip to review, and then this will take you to the next, where you can basically take the standard settings and then go forward to create basically the application. And depending on the settings it should basically run. So submit, that's the step, and then now you will see it is getting prepared, the test environment, health, and once the health is ready, then you will be able to see the application run. So that's a very simple way of deploying an application. It's not very detailed. I just wanted to give you an initial introduction. Later, we will go into detail of each steps and explanation. But that's the general idea of deploying an application. So once you have the application ready, basically it will, it will then give you a domain which you can link it to the original time. Sometimes you might get that failed to launch environment and all these errors. If you get these errors, then we will solve it later, but mostly this step you should be able to create an application. And if you're not able to create an application, do leave a message, then we will have a look at it, and then I will support more on that. So here I am going to show you EC2. EC2 is basically is a key service provided by AWS. It's basically renting a virtual server. So here you have launch instance EC2 free tier. Be careful, they might say free tier, and once you start using some of their compilations and their tools, they might charge you some money. Here you see you can name the example like web server and select different instances or different applications. Like you can select a Ubuntu server, you can select a Linux server, you can select a Windows or any of the things where your application will run. So EC2 is a quite it's a flexible system, and it's basically a virtual machine instances, and these virtual machine that run applications similar to the physical computers, and each EC2 instance has its own configuration and different types. So instance types may vary, like general purpose, compute optimized, memory optimized, or storage optimized, and it's scalable, and it's a pay as you go pricing. So I just type a web server as a name, and then you select different types of servers you want to configure, and then you press the next buttons accordingly. So I just click on the launch instance, which will take me to the next set of settings, which is like you need to have a create a new key pair, and I'm just going to select the setting as shown. Then I'm just launching the instance. So this will basically give you sort of a remote access to a specific server or computer, and in this case I'm this PC or server or computer, whatever you call it, will have Ubuntu operating system installed on it, which we can basically in that operating system or in that remote computer. It's like buying a computer, you're installing Ubuntu on it, and then you can install the applications and use that. So they give you a private IP address, and all the settings are pre-configured for you, which can be customized and used according to your needs. So EC2 is quite easy to use, and it also has load balancing facilities, and it's flexible, scalable, and cost effective solution for launching your applications. The good thing is they have a free tier, which is for a certain time limit you can use it for free, and then depending on your usage the price is calculated. Do be careful on what services you use, and read the notes about how they charge you, because sometimes the things might charge they might charge you on a basis of your usage. So that's a very basic instance of how you can basically run an instance of EC2. Here I'll show you how you can basically so you see here the instance summary is running, the instance state is running, and you have a IP, but due to some reasons I'm not able to see the when I click the domain name which is given, the server it's not responding. So let's see why it happens and how to solve this. So here you click the connect, and then it connects to an instance here, and some of the settings are as shown. Then you click connect, and the username is already set, and then once you set the connect, then you're connected to the instance of that system. Now you will see the console where Ubuntu is running, and you can issue some commands, or you can install Tomcat server, or you can install your application, and then from that application your web application can run. So it is a simple Ubuntu system on a remote server, and that's what is basically EC2. And here you see I can issue some specific Linux or Ubuntu commands, and then you have access to this specific hardware resource, which can be used for any of your application purposes. So here I'll show you the dashboard of Amazon AWS. So once you create an account, you will be taken to this. So here I'm showing you the bills and payments. So you should be very careful, because when they say free tier, it could mean a lot of things. So you have to read exactly. So here I subscribed for free tier, and then I used some VPC, and then they started charging me. So I assume VPC is not included in the free tier. You see here I have used something, and then default services mode Amazon virtual cloud is being charged. So these are some things which you have to, and they will also show you the root cause of how the cost is breakdown. It's quite clear, but it's quite complex to understand. So these are some things which you need to understand and see how it's being used. So you see that VPC I've been using for, it's been active for 27 hours. That means once you start this VPC virtual private cloud, it keeps running on the remote server. That's what it's cloud. So you start something here, and what happens is on a remote server, on remote computer in Amazon, something keeps running, and then you will be charged. So this is what is included in the free tier part, like 750 hours of EPC and stuff. So all the things which you use here within that limit, on the free tier usage limit, it's free. All the others which you click and then add, they wouldn't warn you that it's paid. It's just like it's just taken. That's the way AWS works, and many of the payment systems are working today. So there are a lot of hidden things, hidden costs, which you need to be aware of when you're using AWS free tier or paid. So in this is very elaborately explained in the bills and cost management stuff which you see here. And you see here Amazon virtual private cloud is being charged with the blue things, and there's this red is the tax, and the others are not charged. So here you see VPC is the virtual private cloud. That is the first one. Let's see what I have been using, and I click on the VPC, and you see this is the VPC dashboard, virtual private cloud dashboard. And here you will see all the things which is needed. The first section is your VPC, and when I click there, and you have other options like elastic IPs and stuff. So I don't see the VPC server running there. So let me just go to another location and see why is there why that section is empty and what has been running, to understand the charges which is starting to occur. So these might be small charges, but once you log in and forget, or don't take care of it, these costs could sum up to so then you have the EC2, which is which is another resource where you can use and you here it's clearly stated EC2 free tier. That means it's a sort of so EC2 is Elastic Compute Cloud. It's a web service provided by AWS that allows you to rent virtual servers, and you can use the instances in the cloud. And here you see different options. Here you can Amazon EC2. It's quite explained in detail what EC2 is, and how it's scalable, and compute resources you can use as much as you need. And when your requirement increases, demand increases, then it scales up. And there are different instance types, and you can read through all these. It's a bit complex, but take time to understand what EC2 means. And there's also pricing which you need to understand, and here you see 750 hours of 12 months with free tier. So you have a free option, but it's limited to 750 hours which you need to. So if you're practicing cloud computing cloud, you can use this free tier to learn about how things work, and then this will be a good option for you. So browse through the system and learn more about what is EC2 is, and what are the pay structures, and how it works. And it also offers on different operating systems. That is, a remote PC could be a Ubuntu or a Windows or anything, and they give you options like Linux, Windows, and other options. And this EC2 is quite useful if you're in learning cloud computing and if you want to try out a lot of stuffs. So AWS has a lot of other features and functions which you can have a look, like Amazon Q, VPC is here, and most of the thing is VPC or RDS is what is used. This is virtual private cloud, which I was said gives you the virtual environment, and cloud in the sense like, so elastic compute is also cloud and virtual private is also cloud, but in virtual private cloud you will have a system like a remote system and a console login where you can log in and then use, if you are renting or if you are getting a Ubuntu system, you will get a Ubuntu console and you can install anything or run some systems or run some, for example, you can run a Tomcat server and then an application and then link this to another domain. So it will be a dedicated web server or website where you are running. So you have RDS also, which is basically a database system like MySQL. You can use Oracle or stuff, which is also options are there for you to use Amazon RDS. These are some of the things. Major is Amazon EC2, VPC and RDS. You can have a look at it. These are the three main cloud features which is widely used, and if you are into cloud, learning cloud, these are the three things you need to start to make analysis, research, and then understand these three concepts. So once you have an understanding, then you can also start using it practically. That will help you a great deal in understanding what cloud computing is, what are the things which we can use. And this is identity access management. It's a web service and it uses a it's a secure AWS service that helps you manage access the AWS resources. It's a sort of a security thing, and with IAM you can define who has access to which AWS resources and what actions or they can perform. It provides a fine-grained access control system. So it's like giving specific rights to specific users, and you give specific access to specific users, sort of admin thought of things. So this is all done in Amazon IAM. In this video, I'll explain about how to manage Amazon AWS resources in a cost-effective way, and just to stick to AWS free tier, because Amazon might charge you on some of the things which is not in that free tier. So I'm just going to demonstrate that. And here and it's important that you manage the cloud resources effectively to avoid unexpected costs. So when you're experimenting with the AWS free tier as part of like just to experiment and see what works and what not, you might be incurring unnecessary charge. So that's the idea of this video, to help you control and use AWS free tier. So here you see the dashboard. You see there is a my zero spend limit budget which you can set. I'll just show you currently how you can do that. So this is the billing and cost management, and there are some small costs incurred, and you see different costs are colored in a different fashion. This is the free tier. You have 671 hours for Amazon EPC, Elastic Compute Cloud, and 80 to 89% is used. You'll get a mail notification, and then you have Amazon. I have created one before and then I deleted, so that's also added. And VPC, these two things, virtual private cloud. So you have to be careful in using and tracking all your usages. You see that month to data usage and everything is clearly described in the dashboard, but you need to really look into what you need and what is not necessary. You just delete it or remove it. So here you see there's a cost monitor and there's one active budget. So if I have created an active budget, you can create a new one like in the create budget. So here you can set it to different levels. You can set zero spend budget. That means it won't go over the free tier, and you have different templates which you can analyze and set your budgets accordingly. Then you will get notifications if some costs go over a certain limit. So and you can add the mails there. So this is a nice feature from AWS cloud, where you can control your cost and manage the cloud resources effectively, because it's and this is also, there's also a bar chart where you can really see what is being used and which is being charged and which is not. So that's about billing and cost management. You see on the left side you have EC2, and I click now EC2, which is Elastic Cloud. This platform will show you what instances are running. Now you see here, instances running is one. There is one EC2 running, and that is almost consumed 80% of the free tier allowance I have. And if I click the instances, I go inside and you see this instance is running, and you can see the running mark. And there's a public IP, there's a private IP. You can host a whole lot of things on this server and run some things. So here I can terminate or delete this to stop or avoid getting more usage, because it's just simply running and it's not doing anything, and that will be counted as a free tier. So I'm just deleting it so that this can be stopped, or you can also stop that server from getting used. Since I'm using this as just to teach and as a platform, I am deleting it and adding it. So feel free to use the free tier to the maximum possible. It's quite a good exercise if you are learning cloud computing. So EC2, when I now after deleted, I refresh it, and then you will see that instance which was running will disappear, and then you are freed up some resources on your cloud platform. So you see here, here in the summary you will see all the regions. Then I click EC2, which is the virtual servers in the cloud. And as I said, this is the cloud computing what we are talking about. And the instances, you see it's 0 now, it's not running. You have only the security group, and there's one more instance which is running here, which is the T2 micro. Yeah, that's the one which we just deleted. So that's terminated. That's the status you have. For it to disappear, it will take some time. So that's about EC2. Then you have VPC, which is also incurring some, it's just taking some of your free tier allowances which you need to control. And you see here VPC, there are we need to find out which instance is running, and we need to track it down. So I'm just going to click on VPCs here, and then you see this is also green VPC, which is virtual private cloud. And in the actions you can create, I have not selected. So when you select, then you will see some of the options like delete VPC, which, or you can disable it. So here I'm just typing to confirm deletion, type delete. You need to type it, and then you see this resource will be deleted. So be careful if you have already hosted something. It all depends on your requirement. Yeah, then don't delete it, just deactivate or disable it. I'm just showing you how to delete and how to enable it here. So be careful when what you're doing on your cloud resource. So this is about EPC and VPC and the EC2 platforms which I have shown. This is a complete dashboard, and you need to, here you can see the billing and cost management. Top right corner you can see a dashboard where how the costs are managed, and keep track of it, and also monitor the usage. You see nice graphs here, which is blue is Amazon Virtual Private Cloud, and EC2 is green. These are the two things, and it just gives you an idea of how to monitor. And in this summary you can see what are all allowed in free tier. That is here 750 hours, for which 90% I have already used, and there's another 66% and for data transfer and the other requests. So you need to know each of these. I'll try to explain one by one in this course in the succeeding videos, but also try to read what it means before you use any cloud resources, because cloud resources are normally mostly charged. Any cloud, because you're using a remote computer of some company, and naturally they will charge you for these services. And Amazon gives you some free options initially, and then they will start charging you, because no one will give you free forever. So this is just like a marketing thing to give you an option, and once you get used to the dashboard, once you get used to their system, then they will start charging you. This is the normal trend which is here. So here in this billing, you can see the total cost, VPC, and all the services you're using and how much cost it costs. So keep track of all these things, and this is a very good practice for you if you're learning cloud computing. And here you can also specify the date, how much you have used within a specific date and time. So use the Amazon AWS free tier for your learning purposes, and that's a good thing for you to learn and get used to the system. And if you have any questions, do give me a message. I can help you on that. Let's look at Amazon, another functionality or another cloud platform. Amazon RDS for MySQL is easy to manage relational database. So you have a database which can be hosted on a remote computer, and you can use MySQL from Amazon. So it's a database which is on the cloud, and you can have a login and password, and then you can link this database to your web application. This is also one form of cloud where you don't have the database locally in your computer or in your company. You can just put the data or the database in a remote system, and that's where Amazon offers this RDS for MySQL. That is, you can create a MySQL database and link it to your website. Like for example, I have MySQL database for my Queryed website, and I link it with a MySQL. I'm not using my from Amazon, but I'm using another platform, but it's similar. So AWS offers this platform which you can use. So you can go on and read the documentation. Like for example, when you click on this, you can see the resources, the database instances, and there's a create database. That's where you create a database which you can link. So there are different kinds of databases which you can use, like Oracle, IBM, SQL Server, or MySQL, MariaDB, Oracle, any of these. Instead of buying these databases, what you do is you just pay a subscription fee to Amazon, and they offer you all these databases. They have all these systems and applications installed in a remote computer. You just pay their monthly subscription and you have a database. So continuing, I can create a database by clicking on that, and then you can do settings, easy, create, or standard, and select any of these databases depending on your application or depending on what your requirement is. And they have given 3 options. Free tier is like there is still a cost, so be careful in what you're selecting, and it depends on the stuff. And you put all these basic settings, like self-managed is basically it will generate which password, or managed by AWS. And then you have EC2 connection. You can connect to, if you have a EC Elastic computer, that is remote computer also from Amazon, you can link it here. And that's the settings. And then once you create database, you'll have something like this, and the database will be created. Then once the database is created, all you have to do is link this database with your web application, and then you're good to go. So finally, I managed to create a RDS database in Amazon. So as you know, Amazon RDS is like a cloud remote database. So you can create a MySQL or any type of database on a remote computer, and that's what Amazon RDS is. And here, if you see, I have created database 1, which is marked as available. And this database, I'm going to link it to my application Queryed, which will be hosted on a different platform. So if you click monitoring, you can see some of the usages here, which you can, each block indicates a separate usage instruction. And this is VPC, virtual private computer, which I'm using Ionos here. And here I'm going to start the Tomcat server. Here's where I have deployed my Queryed Java application, which is a .var file. So I'm using the startup to start the application. I'm going to start the Tomcat server, which will basically load the web application. Here, that's the command, and you can see some of the messages. So here, startup.sh is the script which I'm going to use to start, and you see the Tomcat server started. So once it's started, it will be running on the remote VPC cloud computer, which I can access it. So now let me show you. This is the Tomcat, and you see the IP address and 8080 protocol. So this is where my application is running. The Tomcat server is what is you are seeing now. So when I say QED, it should load the application. This is my query application, which is a .var file. So here this is FileZilla, and here is where I have loaded the var application on that IP address, and I can connect with FileZilla and update the file. So here you see web apps is the location where I have this. You see QE8.var is there, and QE8 folder is there. So you just have to put the .var file and start the Tomcat server. Then it will unpack and put everything in the QED, and that's what this application you're seeing. This is a typical cloud demonstration what you are seeing, where I host an application, and the database used is MySQL on Amazon AWS RDS, and the application itself is hosted. This is the database which I have, which I'm using. I'm connecting. This is Microsoft Workbench, and that's the database I'm connecting to. So I'm connecting to the AWS RDS database from the Workbench, and you can see here, and I have .sql file which I have downloaded from my previous database, and then I'm just uploading it in this Amazon RDS through Workbench, and then you can see here in this database I will store the users, the courses, and all these things. So that's what I store in the database. So once it connects to the database, you see this QE application will connect to the database of Amazon, and then gather all the information which is in the database, and that's what you're seeing. So here that's a simple demonstration. I'll just in the next slide I'll explain how it works in the block diagram. A very simple block diagram, what I'm trying to do, or what I have done in the last video. So you have FileZilla. FileZilla is a FTP system. FTP means you can put files on remote computers. Like you sit here and then you can put a file in Amazon cloud or in Ionos cloud or some remote computer. So you'll get an IP address with which you connect to. Here I have linked. So with FileZilla you can upload your files. That is your website. That is .var file, which is a website application, and I use FileZilla to upload that file onto the Ionos cloud. Ionos cloud, in that I have a remote computer which is a Ubuntu system, and that's a virtual private computer, and in this remote Ubuntu system I just upload this .var file in web apps folder, which I showed last time. And this application, once it starts running, so you see how I started the Tomcat server, right? So when I start this Tomcat server, the application loads and it starts working. That is the Query website. So once it loads, it will connect. Before it even loads, it will connect to the Amazon RDS database. This is Amazon cloud. So this is Amazon cloud is another set of computers. So here I have my MySQL database, from which the application Query will gather the data which it needs, like users or the courses or anything, and then it will display it. And on the right side you see the domain. So if you are sitting in your computer, type in www.queryed.com, you will go to that website. So this is how this whole system works, and any database system works, and I'm explaining you in this in the context of cloud. So here you have two sorts of cloud. That is Ionos cloud, which is a different company. Amazon cloud is a different company. In Amazon cloud I host my database, MySQL database. In Ionos I buy a Ubuntu system and then put my Java application over it. So this is the very brief description of how a rough cloud system might work. This is just one example here. So let's look at Heroku. Heroku is a cloud platform. You're seeing the website, and it's like a platform as a service that enables developers to build, run, scale applications quickly. So it's basically when you have an application, they allow you to host it, and it is designed to simplify. It's a very easy, like if you have small scale applications, web applications, you can host it on Heroku, and it's linked to cloud platform because it's a platform as a service. It offers a platform where you can run and execute applications. It's a developer focused platform. So you can see the website. They have explained you everything here. So what you can do is like you can create a, for example, I'm going to demonstrate in this how I hosted my Java application, which is a var file, and you can host it on Heroku very easily. So as a first step, you can create your account. It's creating an account is free. You don't have to pay anything. So you see I have entered my details and I have click the create account. It says it's you have to check this and then create an account, and then it will send you an email which you can basically authenticate. So once your email and then enter some details about you, and then you can set the password and then you can log in. So here I got it, then it says you are entitled. So you can set a multi-factor authentication if you want, but if you want to do it later also fine. I just say cancel so that you can do it later. It doesn't let me in. Let me see. Yeah, so it does ask you to do any three of these: Salesforce or one time or a security key. So once you get through the Authenticator app is basically you can either use Google or Microsoft Authenticator app. It will give you a code which you enter, and then once you logged in, you're there. So then you say accept here, and then you're inside. So there are different things you can do here. So basically Heroku is you can host applications. So you can add a payment method, like when you click they have different kinds of billing methods. Dynos are basically you have to, I'll explain bit detail later. So these are some when you have a application running and you need to use some of their services, then you subscribe to Dyno, which is like $5 a month. But generally it's quite cheap, like it's not expensive when you want to host an application. And you have the account details here. You can enter your password and everything. So the main thing you want to do is here you have a dashboard, create a new app, create a team. So this is what is important here. So I can create an app here, and then like QPP, I just name it, like I'm just going to say, and then you can add a payment method if you want, and then add pipeline, or it's like a continuous generation. So you need to be, I think app has to be like a unique name is also not available. Let me see, try this this one, or let me try one. Okay, so this name is available, and then it says you see the green, then you can select either of these, and once you add the payment method, I think you will be able to create an application. So that's the basic step. But Heroku is an application, is a cloud computing platform where you can deploy application, and how it relates to cloud computing is Heroku runs on a cloud infrastructure. It uses Amazon Web Services, AWS in the background. Which means application hosted on Heroku are deployed in the cloud. Developers can deploy their apps anywhere and scale their system. So here you see how in the Heroku website you have different documentation. You can browse through and have a look at it. It's quite elaborate, defining an application, what is an application, how you run the application. These are, because when you program an application, when it's a web application, you need some remote server to run on, and that is what Heroku offers, the platform. Like for example, here you have Java, all these codings are there, which I will show you later. So you can basically execute all these coding and Java to run on a specific remote server, and that's what is Heroku. And running the applications on Dynos is like they give you certain way of pricing models. Depending on that, you can buy and deploy your applications. So here I have created an application QEd, which is my query ed application, and on the right side you have data clips, elements, and documentation. And when I open the application, you can also create a new application like that, create new app, and then once you have a name, you can create an app. Once you create it, it will pop up like this. And here when you open the application, this is how the dashboard looks like for your application and the response time. And then in the deploy is the place where you can deploy your application. Here I have main branch, which is linked to my GitHub, and another branch. So whichever branch I want, I can basically select that and then deploy it, and it is directly linked to my GitHub account. You can also link it to different repositories. And in the metrics, you can see how your application is doing, and the activities, who has checked in and what, and the actions access is who has access to these two things. So this is the basic thing. So you log in and then add the payment method, and then you can create application. So initially it's everything free, and then later when there is charges, they will tell you. So it's not expensive. So if you're wanting to learn about cloud deployment, how you deploy applications, Heroku is the best thing. AWS is far more complicated. I have tried it. It is very complicated. If you get it working, I was not able to get something working, and it took so much time. So if you want a quick start, Heroku is the best cloud platform you can explore. Now I'm going to show you the Iona's dashboard in this video. This is the dashboard, and here you will see a different services which is offered by Iona's, like servers and cloud here in this case. And when I click inside, you will see like I have bought a server like the VPS. This is the virtual private server or cloud, you can say. And here I go into the remote console where I logged into an Ubuntu system. This is where my query ed application or QEd application I'm going to launch. So this is what is a cloud server. So I have a remote Ubuntu system or a remote computer somewhere where I log in and I host my application. And this I have got it from the company Iona's, or you can get it from AWS or Microsoft Azure or any company. But this is the basic. So here you can see I can execute Ubuntu's commands. I can put some applications inside this, and that's the basic. And I will show you how you can launch an application on this if you follow this videos. So in this video, I'm showing how you can deploy an application on the cloud. So here you see my application query ed. So this is a Java application. As you see, it was not working on one version of Tomcat. I got some errors because it was in the cloud, that is Heroku. They have a different Tomcat version compared to what I have. So I am just changing some code, changing Java X to Jakarta to be compatible with Tomcat 10, I think, in the Heroku system. And once I update all this, it will compile and I can export the application. So all the imports I change to Jakarta, which will be compatible with the Tomcat version, and then I will export it to a WAR file, and then I will deploy it on the server. That's what I'm going to show here. So I'm just cleaning the application and then creating new jar files, which will be all compiled into a WAR file. So jar, Java archive files, and WAR is also an archive file, but it's like an executable. So now I'm just running it directly on the local Tomcat server, that is 10. So for 10 you need Jakarta. Yeah, I had 8 before. So now you see on the local host it's running. You see it's a local host, means in the local computer this application, this is Java application, it's compiled and running. And that's the first step. So the next will be to basically export it. So I'm going to export as a WAR file, and then I'm going to store it somewhere. locally. This is, I'm just exporting. That is, it basically compiles or compresses all the Java archive files and the Java executable files into one whole zip file. That's what is a .war file. This is FileZilla. So I'm connected to my server, which you see 217, and on that server I'm going to copy the WAR file on the web apps. So just watch carefully. I'm copying it to the web apps folder on my server, and then once you copy it, then you just have to start the Tomcat server on the server. Then it will unzip the whole qed.war into it will create another folder called qed, because it basically unzips the qed and then creates this folder from which the Tomcat server will fetch all the files it needs. So now I have put it, and you see a qed folder is already created because I already started the Tomcat server. So here is my console, that is my server. I'm logged into the server, and this is a Ubuntu or a Linux console, and here I'm going to start my Tomcat server. Once it starts, you will see so the startup script is startup, so I'm just closing it, shutting it down because it was already running to show you. So now I'm going to start a startup script, and it's now says it's started. That is, the Tomcat server started on the server. And once it started, it will look like this. This is the Tomcat server front end page. So you see the IP address, and it runs on 8080 port, which is the default thing. So once you have that, then I have to access the application. So how I access the application is inside the Tomcat in the web apps is my qed folder, and that's where I'm going to access it. So now I'm just going to show you restart the commands for starting and stopping. So I'm just going to restart the Tomcat server so that it extracts the whole qed.war file and creates the qed folder. And you see here, this is the qed folder which I told you, inside which you will find all the files which is from my application. And now since it's unzipped, now I can just go to this and put at the end QED, and then the application will basically start, because this is how you host an application on the cloud. That is, this server 210 is a sort of a cloud server, and I'm using that server, that is a remote Ubuntu server, to launch my application. This is a very basic introduction into how you can launch an application on the cloud. So here you see I have installed Tomcat server on this IP address from the VP virtual private server of IONOS on the port 8080, and on the port 8080 this Tomcat server is running. And if I now try to say examples, there is examples folder there in Tomcat which comes default, and here you see certain examples are already there. For example, this is a collection of examples which JSP provides, and I can basically get certain information from the application. Yeah, so you can run certain JSP or Java applications or any web application, and here you see the examples what you can do, and they have also given you the source code how it works. And this is how the thing. Then you have WebSocket examples also, like chat example, or you have multiplayer snake example where you can just basically move like this. These are some of the applications which comes default, and this is how you host a application on a Tomcat server. This is the basic step. This is the very basic or the first step which I'm showing you. There are this, you can do it in any Ubuntu platform. You can install Tomcat server and put the Java application on the web apps folder, and once you start the Tomcat server, it will run. You can do it also on your local system, but I am doing it on a remote VPS system just to show you how it works. Here you see Ionos VPS at they have different servers available at different prices. Quite cheap. If you want to try out the systems, you can buy XS or S. It depends on the space you have. RAM is increased if you have a small cores, number of cores is increased if you have S compared to XS. 80 GB if you are buying, and then as the price goes high, the services also goes high. So this is some of the thing which is also related to cloud, where you have a remote cloud and you basically run your application there. And the application is like here, which I showed you the different types of examples. So in this video, I'm going to talk about linking of MySQL. Actually, last one of the videos I've shown you how you can link MySQL hosted on AWS RDS. That is, MySQL database is in the Amazon server, and how to link query it with that. That is with Ionos. Yeah. So here I have created MySQL database, that is install the software of MySQL in the VPS server, that is the cloud server of Ionos itself. I have bought a Ubuntu server and I have installed MySQL on database on that itself, and also the website application, the Java application also running on VPS. So I'll show you how. So let's go on to it. So here you see Ionos dashboard. I click on the servers clouds, which will take me to the VPS server where I have, so this is the VPS server with that specific IP, and I'm going to click on that, and then this will open up the console basically. So the main problem I had was the 3306 port, which was used by MySQL to and that was being blocked. So I added to the my firewall policy in the Ionos, which let the MySQL be accessible. Before it was not accessible, and that I took a lot of time to figure it out. So I added this 3306 in the firewall policy, and then it is updated. So this is the virtual machine VPS, and it has a 1 GB RAM, disk space, 10 GB core. That is what we call cloud. This is a remote server. So now I open the remote console. Basically it will open a console where I can remotely log into the server, that is the Ubuntu system somewhere located somewhere. And here I'm going to just restart MySQL. So it is running on the same server and the Tomcat. So Tomcat basically loads the Java application, and MySQL server which basically loads the database, and this Java application will connect with the database also running on the same system. So this basically reduces my cost. Before I was using Heroku for paying them for MySQL hosting the application, and then I was paying another provider for MySQL database. So I just cut those things and then hosted everything on the same system, so that you don't have to pay different cloud providers. So here I'm just going to say check the status of Tomcat, and here you see I'm just going to restart Tomcat server. It's showing some sort of error, but still the Tomcat server is still running, which I'll just show you now. And then I can also I have also started the MySQL system. So here I'm going to start the script for the Tomcat, so that you'll see some response. I start the script and then it says Tomcat started, and then again I check the status. Due to some reason it's showing failed, but anyway the service is still running, which I just verified. So now 227.127, and then the application is QEd. So once I put the QEd, then you see the application running. So this is connected to the database, and the application is in the web apps, as I told, QEd bar, that is unzipped as QEd, and that's the files which is what you're seeing. And this is linked to the database, MySQL database, because you have login and courses and everything. All these things I have stored in the database. So when I make some changes, this is also all going into the MySQL database, which is also hosted in the VPS server. So let's discuss about what are the programming languages typically used in cloud computing. The range of programming languages commonly used. So this video will help you orient yourself to if you are from IT software development, if you want to go development in cloud computing, this will give you an idea of which languages you need to have a good grasp of so that you can enter into the career of cloud computing. Ruby on Rails is used for some cloud applications for rapid development, especially in startups and prototyping. Although less common than some other languages in cloud, it's supported by many cloud providers. It can be used for serverless applications. So first is Python. Python is widely used in cloud computing for automation, scripting, and managing cloud resources. Great for building serverless applications, data processing, and artificial intelligence machine learning applications, and supported by most cloud providers, and SDKs libraries integrate well with cloud service like AWS, Google, and SDK. So Python, apart from cloud computing, is a very versatile language used in a lot of areas like embedded systems, in testing, in scripting, also in web development. So it's a worthwhile programming language to learn, and it has a very lot of libraries used in artificial intelligence, which is a very new technology coming up, and a lot of jobs are being created in this. So Python is definitely a go-to language if you want to start in any IT technology, and it's also widely used in cloud computing, because cloud computing, you are involved with a lot of servers, a lot of hardware, and scripting is widely used, and Python is a well-known scripting language. JavaScript, Node.js is a popular building cloud application. It's also a scripting language, especially Node.js, which allows server-side scripting, and great for serverless functions like AWS Lambda and Azure functions, and ideal for full stack development, enabling both front-end and back-end cloud services with frameworks like Express.js. So JavaScript is also quite a known. It's different from Java. Just don't mistake, like Java is not same as JavaScript. So learn JavaScript. Go language. Go, known for its simplicity, concurrency, support, and efficiency, frequently used in cloud infrastructure and development tools like Kubernetes and Docker, preferred for high performance cloud applications due to its lightweight nature. So Go is a very new language, so do explore that language. It's also used in cloud computing. So Java is another, known for stability. Java is a popular enterprise level cloud applications frequently used for backend development in cloud services, especially with its strong support for multi-threading and concurrent processing. Many frameworks are there, like Spring is a very common and is a wanted framework, are used in cloud-based microservices and distributed systems. So Java is another very important language used in backend and also for enterprise level cloud applications. So cloud and programming skills, if we need, here we look about if we need programming skills for cloud computing, and what are the main requirements and what are the different domains. That's what we look in this video. So the need for programming skills in cloud computing depends on specific role and tasks aimed to undertake. Here's a breakdown. That's what we look into this video. That is different scenarios where programming might be needed or might not be needed. So we'll be looking at the cases where programming is needed in cloud and where programming is not needed in cloud. So if you don't want to do programming, still cloud technology is a good career path for you to take. If you want to do programming, so also there's a way, there are sections of where cloud areas where you can program stuff. So cloud architecture, roles and tasks in cloud computing. So cloud architecture and infrastructure management. In this case, programming is required, limited like scripting programming, Bash, PowerShell for automated configuration. Tasks will include designing cloud architecture, managing cloud resources, setting up networks, ensuring security. Skills will be knowledge of cloud programming like AWS, Azure, Cloud, Google Cloud, understanding of networking, security principles, infrastructure as code, and tools like Terraform or AWS Cloud Formation. So here you will need scripting knowledge. Scripting is basically executing a set of commands together. That is what is scripting. So it's not really programming, but still you can call it programming, but it's not difficult. That's the main point. So designing of cloud architecture, cloud resources. This is what will be required for cloud architecture and infrastructure management. So for cloud development, programming is required. Tasks will be developing cloud native applications, serverless computing, building microservices. Skills are proficiency in programming language like Python, Java, Node.js, understanding of cloud SDKs, APIs and services like AWS Lambda, Azure Functions and Google Cloud Functions. So that is for cloud development. Development means you will be actively developing applications which is basically running the cloud services. If someone is accessing a computer remotely, so you might be involved in developing those applications. So here you would need extensive programming knowledge, and Java, Python, everything are very heavily used in network programming. So here it's a good way to learn programming and also go into the development in case of cloud development. So cloud operations is DevOps. Programming required, yes. Programming primarily for automation, continuous integration, continuous deployment pipelines. Tasks typically could include automating deployment process, managing CI/CD pipelines, monitoring and logging. Skills will be scripting, Python, Ruby, Bash, tools like Jenkins, GitLab, CI, Docker, Kubernetes, and configuration management tools like Ansible, Puppet and Chef. So these are some of the things which is required for cloud operations management, where you will be managing the operations involved in like deploying, like automation, continuous integration stuff. So that is cloud operations. So data analysis and machine learning, programming required, yes, for data manipulation, analysis and model development. Tasks will be analyzing large data sets, developing machine learning models, deploying models in the cloud. And skills will be proficiency in data analysis language like Python, R, knowledge of big data tools like Hadoop, Spark, cloud-based machine learning services like AWS SageMaker, Azure ML, Google AI platform. So these are some of the things which is needed for data analysis and machine learning. Since we are using in cloud, you will be handling a lot of data. So this is the thing which is required for data analysis and machine learning. Since it's data analysis, machine learning will be naturally deployed, because machine learning is an algorithm which feeds on data and then processes it, extracts information and gives it to some people. Yeah. Cloud security's programming is limited, mostly automation, custom security solutions, implementing, managing cloud security, compliance, identity and access management, understanding of security principles, cloud security rules and basic scripting for automation. This is what is cloud security is mostly customizing, configuration and using different tools. So this is what will be required in mostly cloud security. Cloud administration will be almost very less programming and managing user access, monitoring resource usage, cloud, setting up cloud services. Skills will be familiarity with cloud management and basic cloud services. It's a typical admin job without very less programming. Only you will be using tools, and you will be maybe, once you learn the tools and the things which is used for the administration of the cloud, like adding new users, removing users, adding new companies and all these things, then this is the cloud administration. So on a conclusion, there are non-programming and programming roles. Non-programming roles will be cloud administration, will be basic cloud infrastructure management, and some aspects of cloud security might not require deep programming. Programming roles is cloud development, DevOps, data analysis, machine learning and advanced cloud architecture, and require programming skills. So programming is beneficial in case of automation, writing scripts to automate repetitive tasks, deployments and management, customization, building custom solutions and integrating various cloud services. Efficiency is developing efficient scalable applications and infrastructure. Innovation in leveraging on cloud native technologies to create innovative solutions. So these are all roles in cloud computing. Some might not require programming. It all depends on your nature of the company or how nature of the task, nature of the job. But mostly cloud computing will require jobs, some which I specified, some might not, depending on things, but it's still beneficial to learn a bit of scripting or programming so that you gain knowledge on that. You can check my other courses on this concepts like Python or Java or any other languages.